Hello, and after a short break, welcome back to Material Matters with Grant Gibson. That's me. I've been doing this for 3 years now, but for listeners who might not have heard it before, the idea behind the show is that I speak to a designer, maker, artist or architect about a material or technique with which they're intrinsically linked and discover how it changed their lives and careers. Today I find myself at 15 Clerkenwell Close in London to talk to its architect Amin Taha of Groupwork about the material that defines this extraordinary building. Stone. Amin, who also happens to live and work here, has been described as London's most controversial architect. And I think to general surprise, the building was shortlisted for this year's Stirling Prize, the UK's most prestigious architecture award. It came as a shock, not because 15 Clerkenwell Close isn't a smart, witty, genuinely eye-catching, and it transpires sustainable piece of work which subtly references the area's history, but rather that it was issued with a demolition order by Islington Council for non-conformity with submitted plans 3 years ago. Happily for us all, Amin won his appeal and he's taken the thinking behind the building, which uses stone as a structural frame rather than as a facade for steel and concrete, to investigate how we might build towers in the future that could be carbon negative. As the writer and critic Tim Abrahams has pointed out, what sets Amin's work apart is his fundamental rejection of style as an orientating device in favour of structure. In other words, this is an architect for whom materials really matter. Amin, how are you?
Very well, thanks.
Thank you very much for doing this.
Thank you for inviting me.
Was that a reasonable intro?
Yeah, it's very good.
Everything
very good.
accurate?
Yeah, absolutely. The FT did say the most controversial architect in London, which I still... just because we were issued with a demolition order doesn't make us controversial.
No, it's an interesting... I was going to ask you about that because it's a slightly curious thing, telling somebody they're controversial to their face. When you set out to create this building, I mean, obviously it wasn't your intention to get into an argument with Islington Council, but did you realise it would divide audiences?
I'm not sure I think we probably realised it would... not necessarily divide audiences, but it gave us an excitement when we saw the stones being lifted into place. We'd already known and discussed with the case officer that we wouldn't know exactly which stone would face which direction, what finish would be placed where on the building, because we'd only get the stones about 2 weeks before they're delivered on site. And of course, as they're coming on site, they reveal themselves, the actual finished elevation reveals itself. And of course, that's, for us as architects, very exciting. Instead of having drawn something 3 years, 5 years previously and expect it to be exactly as you've drawn, which is often a disappointment because you might have spent a long time literally drawing it by hand, shadowing it, making beautiful images of it, or even by computer renders. And they are never what they are in reality. And the reality should be the pleasing outcome as opposed to a disappointment of the constructed image 3 or 4 years beforehand. Yeah. So for us, yes, it was exciting. We expected other architects or engineers, because obviously a highly engineered bit of structure, to be equally excited. And inevitably, yes, because it's different, some raised eyebrows, but not necessarily a certificate asking for it to be demolished.
No, I mean, maybe we'll talk a little bit about that later. I mean, I know you've talked about it at some length in the past. I mean, I was intrigued researching it because I hadn't realised that it was actually shortlisted for, I mean, really amazingly, for Building Design's Carbuncle Cup. They described it as ruin porn. And I'm wondering, how does that, when somebody does that, how do you feel about that?
Tricky one, isn't it? Because it's the sort of playground stuff, isn't it? If you put yourself back in a playground, really, it shouldn't really bother you at all. But of course it does still hurt in some ways. But you're an adult and you can brush it aside. But I think the only reason I took it particularly seriously at that time is because we had the demolition order. And of course, it just adds fuel to this particular councillor's opinion that it's ugly. They hinted that it was possibly him pushing for that because he'd been on a campaign to demonstrate other people think it's ugly. And he'd been phoning lots of architects and conservation groups asking for support, and they weren't giving it to him. So it became conflated with his campaign, with this particular person's campaign. So I think that it hurt for that reason, because you realise, well, he's politically gaining momentum for his purpose. And that's really what this whole thing was about. You naively think, well, at some point people will look at the paperwork and it's fine, but actually politics can completely overwhelm and drive that purpose as opposed to what you think is just facts on paper, approvals, etc.
Maybe we'll get into that in a bit more detail later because we want to talk people through the building. I mean, in the first instance, it'd be quite nice to know how things are going. I'm having to ask everybody this, obviously, when we've been doing these for the last couple of years. We've had the COVID crisis, there have been lockdowns. How has it affected the practice? Have you coped?
Initially, some clients put things on hold. They're worried, looking to see how things will pan out. So we suspended some projects, and I think within about 6 months or so, they pretty much all came to life, and a couple of new projects arrived as well. We initially thought, how are we going to run the office via Zoom and etc. remotely, because we're most of the time always huddling in a group, looking across drawings and details in discussion. And I didn't think, as the senior member, grey-haired member, didn't think that online software would do it. And flapping my arms about, I was eventually pulled towards the screen and told, look, it's so easy. And here's a pen on a touch screen. It can work. And yeah, it was a complete revelation. It works brilliantly. In many ways, it works well. In some ways, it works better than being physically around a table because you can get more people on the screen and everyone can actually annotate a drawing with their opinion, which you can't do physically. However, you still need to meet physically, other design team members, etc. But generally, yeah, I shouldn't grumble. So far, so good. Touch lots of wood. We're doing okay.
And how are you working now? I mean, have you adopted hybrid methods? Is this how it's working?
I have become incredibly lazy at meeting physically.
Right.
Because previously, any meeting with a structural engineer, mechanical electrical engineer, as well as clients, was always physically come round and into our office, or I'd travel by cab or tube somewhere else. And now, can't we just do this meeting by Zoom, please, or Teams? Because a lot of the meetings are general agendas and ticking those off as opposed to anything particularly detailed.
And the team, are they coming in regularly? I mean, you have people downstairs, but how are you working that practically?
Almost everyone's here all the time. One person whose family was Spanish-based and they were in lockdown there is pretty much all the time in Spain. I think he comes over I think you just saw him comes in maybe every 2 weeks for 2 days. That's, otherwise, everyone's here.
And the Stirling Prize.
Oh,
Should we talk about that? It was the second time, isn't it, you've been nominated? It must come as a nice surprise. Had Reba tipped you off that you'd be shortlisted?
No. Well, I've been on that jury for about 6 years,
right.
national, international jury. So you know how the judging proceeds. There's about 600-700 entries every year. They go through regional awards, so the local regions, and specifically here the London region, initially pick buildings. They then get elevated to national for consideration for national award, and the national jury decides whether, yes, it deserves a national. And then they spend 2-3 days deliberating on those to create a long list of projects. If your project is under consideration, you actually have to leave the jury.
Right.
So you don't have a clue. And even the drinks event at the end of all this, because it takes months for juries to go from regional all the way to the Stirling shortlist. Everyone's mum, you haven't got clue. You're looking for clues. You're looking for winks or, something or other, body language. But they're very good. Everyone's very good. Yeah, they'd tell you in a sort of Kevin McLeod, Grand Designs type way. And by the way, in front of camera or something. So that's when you find out.
Yeah. So nice surprise.
Very nice surprise, yeah.
Well, look, we're here to investigate your relationship with stone, and we can't really do that without talking about this building, 15 Clerkenwell Close. But actually, you've worked with the material before. You did a staircase, I believe.
Correct. We worked on Caroline Place, essentially a house of 5 bedrooms or thereabouts, a refurbishment north of Kensington Gardens. There they wanted light to come down from roof level all the way down to a new basement level as well. And so a new staircase really had to open up. I have a light well in it. The easiest way of making that staircase work was through lots of winders, essentially create an oval, a helix for a staircase. Now, traditionally, a stone staircase is keyed into walls, rested on another step all the way down from top to bottom, and that's all the way into the early 20th century. Everybody knew how to make that. Stonemasons knew how to make that. And we'd then forgotten until some point in the mid-'80s when Price and Myers were scratching their heads, wondering how this system worked. So as architects, engineers, we'd forgotten. We kept on using steel and concrete, lots of structure to hold up what in the past would have just been the stone steps on their own. So we asked some stonemasons to help us with that. And of course, in this country, it turns out that we're only training stonemasons to work in ornamentation, decoration, restoration projects. In France, they still train them to work with superstructure and specifically those sort of staircases as well. I think of the 3 tenderers that volunteer to look at the project, they're all French. 2 of them are actually based here, one of them based in Italy, but they're still a French group. It was the Italians who got it because I think they were provided a more interesting stone to look at. But they taught us this system, what's called part cantilever, part reciprocal loading. And we actually traveled to their workshop to see how the stone's extracted, how it's cut up. And then we realized actually it's not just something based on traditional skills, but you're using today's technology, software. So the software that we, in our office, we use to draw the staircase in 3 dimensions is then taken by them to their routing tools, their cutting tools, their machinery, if you like, their robotic cutting tools, to divide up larger blocks into the staircases. And what we realized actually was that software allows less wastage of stone. So it occurred to us there's a point where our new technologies can influence traditional skills. And obviously they're then teaching us about those traditional skills as well. We then looked into the history of stone, specifically staircases initially, and other structural ideas in stone. So before long steel beams and reinforced concrete slabs, you could cut small stone bricks, if you like, to interlock with one another to span potentially 14, 15 meters without any intermediate columns. And that's called a reciprocal structure.
Reciprocal because it's relying on itself.
Yeah, exactly. That's right. From one end of the brick to the other, throwing the load, as it were, along its path to the edge columns and walls, which is quite remarkable when you look at it. So some of this was already drawn and conceived in the 1600s, specifically in France again. Some of it was then built within 100 years of those initial concept drawings and ideas, engineering ideas. There are very good examples still standing in France. There are now architects working with that CAD software to cut the stone with robots and all the rest of it, to then bend those flat planes that were conceived in the 1600s to become double curved.
Right.
So they could be barrel vaults, they could be double curved, they could have all sorts. Yeah, it's suddenly taken on a very contemporary feel, as it were.
Yeah. So combining heritage craft with technology, in other words.
Precisely. Yeah. So for us, it was a revelation, a sort of embarrassing revelation, because we realized we're no different to everybody else. We're taught architecture mostly in the drawing sense. We have no real feel for the materials. Materials tend to be colors and textures that we apply in 2-dimensional sense to a drawing. We would like the building to be made of brick. We would like to make partly cut in stone, et cetera, and no idea that these materials actually have potential structural purpose in their own right. And even if we did, we're suspicious that maybe they don't work, and that's why we have to build steel and concrete frames. So it then drew us to seeing whether we could, instead of just using these things as facades or cladding, whether it's brick or stone, whether we could use those materials for structural purposes. I won't get overly technical at this stage, but maybe it'll come through another question.
Well, it's a mixed audience, so we'd need to be aware of that. Because this building wasn't originally going to be in stone, was it? It was going to be finished in bronze, I think I'm right in saying.
Correct,
was a brick. Then it moved to brick before you finally alighted upon stone. So the obvious question is why stone? Yeah. I read somewhere it's because you were lazy. I'm quite intrigued by that. Maybe we can unpick that as well.
Yeah, no, the lazy thing is when I'm in lectures with students and explaining why try and use one material as opposed to, say, a stone column that does everything, the superstructure and the external finish. Fireproofing and all the rest of it, as opposed to a steel column with all its other materials. What I tell students is, why don't you do the lazy thing? It's far easier drawing a stone column and affixing that to a floor plate than drawing a steel column with its fireproofing, its waterproofing, its thermal insulation, its vapor barriers, its connections that have to go through all those layers back to the steel, then get sealed again, to then connect to a fixing on the back of a piece of stone veneer. Now you've drawn that. You might even just copy it from a bit of information that a subcontractor sends you. However, every time somebody decides to change the proportion of the windows or move a door, and these things happen all the time with clients and design team members asking for amendments, even planners asking for amendments, all that has to be redrawn. And it's painful, laborious, and you scratch your head thinking, God, why am I redrawing all this stuff? And then you see this stuff occur on site, and there's a team of 2 or 3 guys putting stone veneer on one column over a week as if it's bathroom tiling. And my sort of pithy request is, be lazy. Just draw a stone column. It will be plonked down within an hour. And that's the end of it. And you never have to redraw that several times.
So that's the lazy thing.
Yeah. But why did it change from one material to the other?
Yes.
Yeah. The long answer is, I'll try and keep it brief. The long answer is, all of us as architects will plan the typical layout of our blocks of flats and offices on a particular site, and the site has all its typical criteria. This one has got 2-party walls at right angles to one another, so that has its own problems in terms of how much light comes into that plan, and therefore where you lay out bedrooms, bathrooms, living rooms, habitable spaces. Where does the sun rise? Where does it set? How much overheating occurs and all the rest of it. While you're doing that, you're thinking, well, what's this building going to look like? What's it made of? Because ultimately what it's made of will begin to determine what it looks like, which I've sort of explained earlier is the way we tend to do things, as opposed to come up with an image on the outside and then to let somebody else decide how it's held up, what the structure is, what the materials are. So to help us make a decision on a choice of materials, we will do general research, sort of if you like, a historical social history research. And obviously this location is deep in it. There was nothing here until the Normans invaded and they built the abbeys. And literally on our site, we would have been within the Augustinian nunnery, but we would have been where the stables are, all the informal buildings, the timber structures. On the other side of Clerkenwell Close, which was the internal road of the enclave, would have been all the limestone structures. So we were being quite literal and saying, we won't build in stone. We will build something that alludes to the half timber structures that were on the site. And again, being frank about our naivety, we imagined, well, it's highly likely our building will be a steel frame. But when we tend to draw our elevations, we sometimes forget the glazing system is not some super transparent material. It actually comes in typical sections, widths and heights. So full height from floor to floor, but the widths tend to be standardized. And that frame, if it's an expressed external frame, or even if it's encapsulated by the glass, behind the glass will be what's called a back-baked element, i.e. you can't see through it. Put that next to one another, you suddenly have roughly 100 millimeters or more width of this blackness going up the building. If you elevate your building and you draw those black lines, they're actually quite powerful to the elevation themselves. And there's quite a lot of metal in them. So we worked with the engineer, which is a piece of software that is self-learning. And you see the software with the amount of metal involved in the glazing system as well as the superstructure. And you ask it, reduce the amount of metal, essentially. That's what you're asking it to do. And how can I express that unitized system in another way? So can we get double glazed units without any metal in them at all? How would that be held up? And the answer is an exoskeleton, in the same way as it's half timber structure in metal, but you galvanize it for weathering, waterproofing, stop it rusting, but you put intumescent paint for fire purposes, and then you put a hot bronze application. So it's vaporized bronze. That's a self-finish on the outside of that. So really what you're looking at is what looks like a piece of bronze sculpture, as it were. It alludes to the half timber frame structures that would have been on the site, literally on the site. You place a diagonal here and there to help the load path go down the facade. And before you realize it, the software has actually modulated that facade in plan and section. So it's actually quite a waveform structure to look at. We thought it looked beautiful. It reduced the amount of steel on a typical building of this size by about 30%. Planner really liked it, case officer. And he's one of those old school case officers trained from a while back, who is, in his opinion, it's, as with all things, structures change. But in his opinion, planning is still structured via the case officer. The case officer is the conduit, the drop box for all the consultation, so including conservation officers, drainage, whatever it is, refuse. He will consult all those people, pull that information, and he will make a decision. So he's the power, as it were.
Right.
I think what he found was that the structure within the planning department, and possibly generally now most planning departments, is beginning to change. The power is shifting towards what are called design and conservation officers. And sure enough, he had a tussle with the design conservation officer who felt he was too busy to really get into this scheme, and popped his head through the door during our meeting and said, I don't understand why you're using bronze. I've read the conservation area guidelines, use predominant materials, it says. In my opinion, the predominant material is stone. And I begged to differ and said, well, actually, in this area it tends to be brick, because at some point since the 70s, since that conservation area guideline was written, it said brick. And everyone's been doing brick ever since in a sort of pastiche way. And constantly, it's a sort of self-fulfilling prophecy that what used to be a mixed streetscape of brick and stone and bits of timber is now predominantly 70s, 80s brick. Nevertheless, he said, try for stone. So we had 2 other projects. Our case officer said, forget it. I'm just going to push for your bronze all the way to committee. We'll get approval for it. But we realized that if that goes to committee, there'll be a battle between the 2.
Right.
And we thought, well, actually, we've got no prejudices against other materials. We can work in any material. Let's just see whether it is possible. So we had 2 projects running, brick and stone at the same time. Brick as a load-bearing structure is actually, it's possible, but the problem you have is that you have to use something like lime mortar. And lime mortar takes a while to go off. So it takes 5 days, 6 days to go off, and you can only go up 4 or 5 courses before it gets squeezed out. So really what you're asking to do is get your bricklayers on site and ask them to leave for a week, then come back, leave for a week, come back. And that means your entire program is double the period it needs to be. Stone, is it possible to build in stone? So that was our question to the design team. And sitting around the same table in the previous building, we asked them, is it possible? Quantity surveyor says, well, the reason that we don't use stone is because it's prohibitively expensive. If you look at the parliamentary officers, the last ones to use post-tension stone, you could have clad the entire building in top series BMWs end to end, and it would have been cheaper than what the outcome was. When was the last time you used stone? Well, I've never have. So how do you actually know? Well, I just know from that building. Okay, so it's a bit of a circular argument for the quantity surveyor. Same with the structural engineer. When was the last time you used stone? I never have. Well, why don't you use it? Well, one, we're not trained as structural engineers, and there's problems with progressive collapse. So ever since Ronan Point, if you take out a panel or a column, does the rest of the building fall down?
Yeah.
Okay, so how do we go? I don't know. I wasn't trained. Okay, so generally the design team's got circular arguments because we haven't been trained. Architects don't know either, obviously. So we went back to those stonemasons and asked them, is it possible? And they just looked at us as if we were fools and said, of course it's possible. In France, we used to call it austerity construction because building in stone was cheaper after the war.
Yes, post-war in Marseille was a particular spot, wasn't it?
Exactly, yeah. So, yeah, there was Fernand Poulon, who at the same time as Corbusier was building Unité up the hill. He was asked to rebuild the waterfront, and of course he built it for a sort of fifth of the price per apartment, the Unité.
Yeah.
But that was their experiment. It was the post-war period, and concrete and steel emblematic of the new period. Stone is the old world.
So stone was a practical solution, but obviously it was also a risk in that case, is what you're saying.
Only when our stonemasons said it's possible.
Right.
And they said, just get the engineer to tell you how much stone you need in volume, in cubic meters, and we will tell you a price. So the engineer used exactly the same software as the previous scheme. It sized all the columns and beams. We gave that as a volume to the stonemason, and the price came out a quarter of what it would be for a steel frame clad in stone. So we said, okay, fine. It's financially viable then. It's news to the QS. The QS has learned something as well as the rest of the design team. Now it's up to the engineer. What is the problem with progressive collapse? Can stone manage it? And his initial proposal was, why don't I increase the reinforcement in the edge of the slab, or if it's CLT, the sort of ridge beam. But that was, again, a sort of slightly perverse solution, because essentially what you're doing is creating a series of bigger and bigger beams that you don't need the intermediate columns. So you get this weird argument that eventually, do you need any of those intermediate columns at all? And then he had an insight and realized, if I increase the plan of our columns, the XY dimension in plan, the volume of the stone increases not exponentially, but quite dramatically by quite a factor. And that is sufficient. So I will only need to increase it by 50 mil or 100 mil, depending on where the column, what load the column has. And that will be sufficient strength, because it's all about internal explosions. So if there's an internal explosion, the columns and beams stay where they are.
Right.
They're already strong enough to take vehicles bashing into them. It's about internal explosion. So that was ultimately the solution. So we found out financially viable, structurally viable. And then the last question left for the architect is, well, what does it look like? How is it what we call dressed? So is it Gothic revival, neoclassical? What is modern dressing, contemporary dressing? And that's ultimately where we found, instead of dressing it, leaving it naked, as it were, undressed, the quarry found, when we visited the quarry and found all the fossils, ammonite shells, quartz pockets, etc., we realized, well, why can't we have those?
I was going to ask, because we've talked for quite a lot of time, but it'd be good for the listeners if we could kind of describe the building, because it's 6 stories, mixed use, there's offices, there's also residencies, you've got a garden on the roof. Maybe we can try and paint a picture of what the building looks like for our listeners.
Okay. It's essentially taking the superstructure that would normally be inside. So most of us live in buildings where there's internal concrete or steel columns, and sometimes we don't see them because they're hidden behind plasterboard. It's taking that structure and putting it on the outside. So it's taking the grid, the skeleton, which is just a grid of either steel or concrete, outside. And here we're doing it in stone. So there's a stone grid of columns and beams, if you like Stonehenge, multiple layers of it instead of a single layer, 6 stories of it. And I say Stonehenge because the columns and beams aren't just clean-cut squares, rectangles. They've been left as quarry found, which essentially means a master block is taken out of the quarry, then split according to what the engineer sized for a column and beam, and left as rough as that. So when you're looking at it, that grid is actually quite rough and textured to look at.
And it's got fossils embedded in it. And
because it's a sedimentary stone, limestone, its fossils are then expressed when you split the stone. So just like finding fossils on the beach, you split the stone and that stone will split across its sedimentary layer in the same way as wood grain splits quite easily. And then within that sedimentary layer is often a revealed fossil of one description or another.
I mean, the stone comes, when you visited the quarry, discovered that it comes in 3 finishes. So the building has these 3 different textures, right?
So depending on the quarry you go to, you've got industrial scale quarries where just giant robotic machines are slicing stones out the quarry, and it's the robot cutting tools will have everything prepared almost perfectly. There are more artisanal quarries where the stones are obviously a bit cheaper because it's 2 guys as opposed to vast amounts of infrastructure doing it. And when it's those sort of quarries, you'll find that they have very simple tools, diamond wire, encrusted wire, industrial diamond encrusted wire that cuts the stone like a cheese wire for 20 meters long. And then they use drills to split the stone, and then as well as then going into the sedimentary layer and sometimes opening it up either with what they call inflated metal balloon or chiseling into it. It just falls open. So there are those 3, in those types of quarries, there are those 3 types of finishes, minimal finishes. And if you're looking to avoid wastage of stone, that's what you live with, the sort of skill of the quarry master to extract the stone and leave those finishes.
And can we talk about the roof? Because that's quite fascinating. You have trees up there, bees, bats, all sorts of things.
Yeah. Every building in the UK now, all of us are aware, every time we got heavy rain, sometimes the sewers overflow and you've got flooding. Every building now, new building, the idea is you have to try and keep any rainwater that hits the roof on site. Don't send it into the sewage system. So everybody has to build, especially if you're in an urban setting. If you're somewhere in a new house, in a rural area, suburban area, and you've got land, you can create a pond to keep that water in. But if you're in an urban setting, you essentially build a sub-basement somewhere. And a sub-basement is effectively like a pool that nobody uses, that you collect the annual rainfall. You then have to have a pump that takes that water through pipes all the way through the building to either water the roof or maybe flush your toilet. So it's grey water usage. It's more infrastructure. And then perversely, because those sub-basements tend to be below invert levels of old Victorian sewers, any water going in from the ground into it has to have a sump that's not allowed to mix with the grey water, and then a pump in that sump. So you've got double pumps, double sumps, infrastructure, all costing not just financial cost, but carbon as well, constant energy being burnt with these pumps, and then replacement of them and maintenance of them. So if you keep all the water on the roof, that's called a blue roof. But what do you do with it all? Do you create this same infrastructure and pump that throughout the building? Or, again, this is the key thing about keeping your design team around the table. At some point, the landscape architect's looking a bit bored, thinking, well, I've done my bit of the agenda. Why am I here talking about sump pumps? And we're talking about the blue roof. And, his brain lights up where ours wouldn't. And he said, well, you do realize that trees will suck up that rainfall. Grasses won't. So as well as having to deal with water attenuation, planning policy also asks us to create, if it's not a pitch roof and a flat roof, biodiverse roofs. And normally biodiverse roofs are just wild grasses that don't have to be maintained, or sedum roofs. Occasionally a piece of timber, the idea is to attract invertebrate insects up there. So it's not just a monoculture. But those grasses will never suck up drink or the annual rainfall. So the landscape architect has a light bulb moment and says, look, if you put one giant oak tree up there, it'll completely absorb your annual rainfall. But the structural engineer is also around the table and says, well, I don't want to deal with a giant oak tree. I have to thicken the slab. How about we have smaller trees? And the landscape architect says, well, of course, we can have 4 trees instead of 1 tree. And if you locate them towards the engineer says, if you locate them towards the end of the skeleton, the exoskeleton, edge of the slab, we don't need to thicken the slab. So what we have up there is a blue and green roof combined. It's the first time we've done it, and obviously the 2 different departments and the council don't normally speak to one another. You overlap them as a Venn diagram, and they finally say, yeah, of course, that's possible. Let's give it an experiment. And it's a revelation to us all that it's flourished so wildly and amazingly.
You worked with engineer Steve Webb, of structural engineer Webb Yates, and the stonemason Pierre Bidoux on the project. I mean, how easy was it to find the people with the right skills?
Well, we've been in practice, I don't try and remember, quite a while. So it takes a while to work with different teams until you find somebody who, well, Steve would put it, you sit in the pub with and have a few drinks and argue and inspire one another. And that's Pierre, the stonemason, Steve, at least one other engineer as well. Can't be all Steve. So it's about relationship building where what I always express to all of them is that none of us could have reached that result. It's a combination. It's only by a constant feedback between one another we will find something that's, I don't want to call it unique, but a better result than we would have found on our own, which goes back to this idea that architects are trained to draw an elevation, draw a plan, and now hand it over to structural engineers and others just to fill in the structure and other details. Similarly, and then stonemason gets hired to just put on the cladding or something, as opposed to sitting around the table, having that discussion, somebody saying, well, why don't you just do it in a block of stone as opposed to the engineers?
But it's more than sitting around the table, isn't it? I mean, you're visiting the quarry itself. You're learning from the material, and the material is defining what you do in many regards.
Take the table away. We're on our feet, walking in quarries or sitting in pubs. Whatever it is, it's about communication, even via Zoom. It's about constant questioning one another, challenging one another, with humor, not bullying one another, and that's how these interrelationships produce good results.
Yeah. So, I mean, from what you said, the benefits of building something like this in stone is that it's quicker, it's cheaper, uses fewer trades, but there must be, well, there is, because you've talked about it, an environmental benefit as well. Can we talk about what that might be?
Yeah, so we imagined we might be reducing the carbon footprint because we're architects, we're not trained sustainability engineers. We imagined just sort of intuitively, well, a stone has got less of a carbon footprint than a steel column and beam, which has to be extracted just like stone out of a quarry as an ore, but with all the other elements then fired up with coking coal and all the rest of it. So it must be a saving of about 15-20%. That's what we imagined. At the end of the project, the sustainability engineer finished his assessment of the as-built and said, what I found was that you've saved 92% of your embodied carbon compared to a steel frame clad in stone. And I asked him, well, how on earth have we done that? Just think about it, Amin. I won't tell you, just think about it and call me back when you've realized. So put the phone down and ask the rest of the office, what do you guys think? And nobody had an answer. We all went home, I'm sure all of us were, standing in the shower still wondering what it was. And about halfway through the next day, somebody piped up, it was laid down 400 million years ago, wasn't it? It's already made for you. It's a pre-made, pre-processed product. The only energy being burned is the cutting machinery, the transportation and erection on site. Phoned him back up and he said, yes, exactly. It's just the energy in those three processes, the cutting, the transportation, erection on site. And he said, had you managed to get a British quarry to give you the stone, you would have saved another 5%. But at the time, British quarries couldn't give us the strength certificates. We would have had to extract pieces of stone from every part of the quarry and then send it for testing to find out which part of the quarry we could take the stone out, while France still does that. Every quarry will give you a strength certificate for the stone from every part of the quarry, so you can choose the appropriate stone.
Well, it just sounds a daft question, but why do the French continue to build in stone where we've seemingly forgotten?
Yeah. The short answer is all their historical towns, each one had to have a group of masons looking after the historical towns, so they effectively created a market, a constant, continuous market after the war for restoration and rebuilding of those historic towns. So there's job creation and a market for, well, one, making sure those stonemasons are still trained that way, and two, quarries are still extracting the stone for that purpose.
From a layman's point of view, while stone is less emitting than steel and concrete, I mean, it's still extractive. If all our buildings and all our cities were built from stone, we'd surely need vast quarries that would have the environmental lobby up in arms, wouldn't it?
Absolutely. Very good question. Now, think about making a piece of metal requires a quarry to dig out the iron ore. There's less iron ore than imagine the Earth's crust is principally stone. So we're sitting on molten magma, and when it cools on the crust, that is the stone. So really all we're doing is acting like termites, extracting a bit of stone here, building it up there. You don't need a lot of stone to put a building up. And if you look at Edinburgh Old Town, Edinburgh New Town, the Victorian Edinburgh, most of it was built from a quarry that is now a shopping centre, a retail centre within the greater town. So the quarries don't have to be big at all, while the quarries for steel and cement are vast, and the energy required is vast, and they are finite. So the iron ore and cement and all the rest of it, we certainly sand for the cement we're struggling with. The quarries for stone to put our structures up will be a fraction of what's required for the other.
I mean, there's a lobby that would suggest we'd just be better off, and I know you've worked in cross-laminated timber, but building in timber, wouldn't we?
Yeah. There's always a danger with these debates that they become false dichotomies. So people say either or. We're never going to stop using steel. We're never going to stop using concrete, cement. It's just about having an intelligent decision process about what material suits what structure. So if we're going to build a fantastic tunnel from here to Ireland, it's highly likely to be in concrete.
Sorry, I'm laughing. Yeah. Sure.
Same with a bridge across the Irish Sea. It's going to be lots of concrete and steel. Could probably do a bit in stone, but it's more likely to be that. So some bits of infrastructure will always require more concrete and steel than stone or timber. So coming back to timber, again, it won't be either timber or stone. There probably could be a mixture. Problem with timber is that you need lots of sustainable forestry, which is not a problem in one sense. There's a professor, Tom Crowther at ETH Zurich, who's finished a piece of research not long ago, which suggests that there's enough unutilized land, so non-arable land, cleared land that's in private ownership as well as public ownership, enough of it to forest. So if we clicked our fingers and all of us went out and planted trees in there, he said within 100 years we'd be at pre-industrial age levels of atmospheric carbon. Now, only a fraction of that forest would need to be set aside for construction industry. And the thing about, obviously, most of us know, is that trees are carbon sequestrating. And it's a figure that you still can't get your head around, thinking that, well, 1 ton of timber holds 1.6 tons of carbon. You think, well, how on earth is
how does that work? Yeah.
But it's so essentially the wood is carbon negative. So if you minimize the amount of processing of that wood, i.e. you've cut the tree down, you've cut it into planks or beams, great. It's still carbon negative. If you turn it into cross-laminated timber or nail-laminated timber, and this is hardwood nails into softwood planks, and it's the moisture equalization of between those that keeps them together, that's still carbon negative. So you know, the thought experiment is that very quickly you can make all buildings out of timber, cross-laminated timber, and all the rest of it, and that building is carbon negative, which basically means that the construction industry goes from being a carbon emitter to a carbon sequestration industry. So instead of inventing machines that have to suck the air into them and draw out the carbon, and then we store the carbon and send it underground or whatever it is, you just plant woodland for construction, and that becomes a carbon negative sequestration industry and accelerates Professor Crowther's idea of within 100 years will be at pre-industrial levels of atmospheric carbon. However, you know, not everything can be built of wood either. So there's bound to be a mixture of stone and wood as ideals of low carbon construction. And we undertook a bit of research for the Building Centre exhibition, where we suggested, well, can you build
the New Stone Age? This was
yes, exactly. Yes. So we titled it the New Stone Age, you know, to grab everybody's attention. Come along and find out whether we'll be living in Flintstone houses or whatever. We went to Canary Wharf and asked them, look, give us your ideal tower, commercial tower, because we just want to do a bit of research to demonstrate, is it the same price? Is it the same carbon footprint or not to build in stone? So we initially started off, they gave us a brief. They said our ideal tower is about 30 stories. It's got a footprint of X by Y, so many lifts and all the rest of it. That's ideal for a single tenant, multi-lets and all that, et cetera, et cetera. So we then directly compared a steel frame, a concrete frame, a stone frame, and also stone floor slabs. So eliminate as much concrete as you can, steel and concrete as you can. The purely stone project ended up cheaper than a steel or concrete frame version, but it still had a positive embodied carbon footprint. It was a fraction, I think like a tenth of the steel frame, and about 30% of the concrete frame. So very good. But it occurred to us, well, can we do another version where it's an exoskeleton of stone for fire purposes to meet fire regulations because it performs very well in fire, but the internal floor slabs are cross-laminated timber.
Yeah.
Other elements internally are all timber. So you increase the amount of timber, and before you know it, what you find is, this is again working with Webb Yates and 8 associate sustainability engineers, we found that you end up with a carbon negative building. So more carbon negative than the equivalent building, concrete frame building, is positive. You compare those, you add those together, and you still have a carbon negative result. So you could hypothetically build two at the same time, and you're still carbon negative, which tells you it's more efficient to probably demolish some buildings and rebuild them continually in timber and stone, and you end up with a carbon sequestrating product and industry, as it were.
Interesting. Coming back to this building again, that 30-story tower you're talking about was based on
exactly,
this, wasn't it?
Extrapolating the research we did on this.
Yeah. I just want to come back to the Islington Council that seems very determined to demolish it, and there are stories of documents being lost, of information being redacted. I don't really want to get into that because it's been quite well rehearsed, that thing. But I think you told DZine when you won your appeal that it didn't feel at that time like much of a victory.
Pyrrhic victory.
Pyrrhic victory. Yeah. That's how you described it. I mean, do you still feel that way, I wonder?
Well, I mean, it literally means, you've almost ruined yourself financially, because that's what the Pyrrhic Wars did. And they eventually left Rome and said, if we beat Rome again, we'll be ruined. And that's what it felt like at the time. You wish you hadn't spent that money. I wish still today that we didn't have to spend that money. I don't want to, you've pulled the string. I'm just going to carry on, aren't I? But at the end of it, our barrister said, give me some money. Now we will sue the council for tens of millions. And you're tempted to do it just to get the money that you spent back, because you don't get all of it back at all. But, lots of advice from others was like, you're going to spend the next 2 years. You've just spent 2.5 years stressed and writing legal letters. You're going to spend another 2.5 years doing this. Then you just want to carry on being an architect. So that was the decision. You
gave a talk for the AJ when you were in the middle of it. You were obviously visibly quite distressed.
Yeah. It's difficult, isn't it? Because people forget, it's actually a piece of paper that says it will be demolished. Whether you demolish it or we demolish it, it will be demolished, i.e. you're going to be homeless, your practice will be homeless, financially ruined, etc. And you have 2.5 years to consider that before the actual appeal hearing. During that time, it concentrates the mind, how on earth did this happen? You blame yourself. It must be your fault. We as architects must have done something wrong with the paperwork. In some senses, yes, there are subsections of planning law that allow you to submit what's called a Section 96, Section 27 or something. I can't remember exactly. I should know, but I shouldn't know.
I'm sure listeners can write in and tell us.
Yeah. I've handed it all over to planning consultants from now on that say every time you make a slight change in the scheme, even if the case officer allows it, if you use one of these certificates, it's indisputable. No one will ever be able to dispute it. And all your drawings are then legally bound to that certificate. And what had happened was that somebody at the enforcement office decided to literally take all the drawings, all the references to stone out, to say there was no stone approval at all. Strictly speaking, legally he wasn't allowed, but it was, in his opinion, it was arguable. And it turned out he hadn't actually asked for legal opinion. He'd just done it on himself as a senior enforcement officer. He thought he was correct in doing so. So you ask yourself, is it ethically correct that somebody can do that? As I said, 2.5 years to concentrate the mind, that when somebody presses a button because he's been told by a councillor to do that, what are the consequences? Does he realize that he's actually potentially making the people who live in the block homeless, including myself, our business, financially ruined, et cetera, et cetera? Or is he just doing it because he's been asked to, and it's just a piece of paper? I've ticked the box, the consequences further down the line I've got no sense of. And you realize that's the sort of thing that's going on. It's not somebody being personal. They don't know you. They don't know your circumstances. It's just several stages up the line, they're wholly emotionally removed and have no ethical connection with what they're doing. They've just, pressed the button, as it were. So you have to set that aside and put it in a box and not think about it to be able to carry on. And then obviously at the appeal, when the enforcement officer is being cross-examined, he then confesses, yes, because he's under oath, I removed all the drawings because I was told that no stone should be in existence. Did you seek legal advice? No, I didn't. If they're all put back in as they legally should be, is there an enforcement notice viable? No, it wouldn't be. Okay, end of story. That's it. And that's stuff you learn not only about ethics but also people who are in a position of power, not only to be able to press buttons for those sort of actions, but actually their decision-making process. So why did they decide that? Well, it turns out that councillor was under because the scheme had got approval via delegated powers and didn't have to go to committee. This councillor sits on the planning committee. He'd made the mistake thinking he ought to have seen it and approved it. And then he just started a campaign which he couldn't press a reverse button on. And it was all about aesthetics to him. I don't like the look of it. And you think, well, how is somebody in that position who's unqualified? Well, one, is it ethically correct that you should be making a decision about someone's private property? It's not a public building. It's not public money. It's not publicly shared, to decide whether they are ugly or not. And then you decide whether they should be there or not. And then, setting aside that he did it without, if you like, in quotation marks, illegally. Why are we putting people who aren't qualified to make those ethical as well as aesthetic decisions? So it concentrates the mind. It's sort of interesting in many purposes as well as stressful.
Yeah, I can imagine.
That you realize, there are some revelations coming on here about how the entire planning system works. How because we've walked into it. We've handed power to people who are unqualified to make these decisions, and you sort of feel sorry for them because they are sitting. You see them in committees, scratching their heads looking for guidance. Is this building ugly? And you think, well, why are you deciding whether it's ugly or not? It should just be strict planning policy. Does it meet the planning policy? Has it got the correct employment use, enough affordable housing, etc.? Not whether you like it or not.
There's a whole debate about beauty here, which I think is a podcast for another day. But I'm very keen to talk about your background because it's fascinating. Your parents came from Iraq and Sudan and met studying medicine in East Germany, which is where you were born. So how did they end up behind the Iron Curtain?
Both of them are born in post-colonial Iraq and Sudan. And what tended to happen in those countries is Britain lowered the flag and a new flag went up, and Britain had put in a friendly head of state, as it were, government, very quickly those governments tended to be, on the whole, they tend to be a revolution of some description or another. And you, in the post-war period, you were either nationalist or communist, and sometimes that literally then divided up into Eastern Bloc or Western Bloc, as it were. And Iraq had its communist revolution, as did Sudan. Their immediate counter-revolutions and counter-revolutions. And in that period, when they were both of them were about 15, 16, communist periods, the Eastern Bloc countries, just like the British Council, would come over to countries and say, why don't you study in the UK? And part of that purpose is, yes, it's good cross-fertilization of cultures and knowledge, but essentially what you're doing is creating a cultural link, sort of cultural capital links to those countries. And those Eastern Bloc countries are doing exactly the same. We will give you scholarships to come and study in Berlin, whatever you like. And they came over and studied, I think my mother actually started in chemistry first and swapped over to medicine, and then met my father after having swapped over that year. They then studied medicine. They had us while they were studying, at least 2 of us, and then a third after they graduated and were working. They didn't have to stay, of course, but what happened was that there were counter-revolutions in their countries. And my mother's brother was actually a nationalist. So he basically called her and said, there's no point in coming over. The entire nationalist party is going out, finding all the communists and shooting them, so you better not come back.
That's a good reason not to go home.
So she was certainly a maroon, same with my father, and they couldn't go back. And she's never been back since.
Oh, really?
Yeah, yeah. Because obviously, post Saddam, Iraq hasn't been easy either.
No.
So they then had to find where else to go. They had relatives over here. This is 70s, and England was looking for, the UK was looking for more doctors, fill in places. So they had relatives who were working in hospitals. So we landed at Southend-on-Sea.
Oh, wow.
Yeah, Southend General Hospital, hospital accommodation, doctor's accommodation.
So you're kind of an Essex boy.
Absolutely. I would have been about 7 years old, I guess. And, Southend-on-Sea.
I know it,
which is a misnomer.
Yeah.
It's on the estuary. Yeah. It's not in the sea at all. When the tide goes out, there's no sand. It's just mud flats. But you quickly get used to it, don't you? Did you swim in the estuary?
Because I am an Essex boy. I didn't go to Southend so much. I bought some electric guitars from Southend. Clacton Pier used to be a family day out.
Yeah.
Frinton, if we're feeling particularly posh, would be with it.
Posher.
But I have swum in that coastline. Yeah. Do you remember East Germany? Do you have any memories of it?
Yeah, of course. I mean, 7 years old, you'd remember it. I mean, but when people ask for memories, they imagine it's some dystopian
they do
images, because that's what
everybody driving a Trabant or something.
Yeah. If you're an adult brought up over here and then dropped in over there, it probably is. But as a child, it's just your environment, isn't it? And there's nothing particularly terrible going on for children. But I think it was a new state, wasn't it? A new post-war state, and it's making its mistakes and errors, and some of them are structural. They can't help it. They're never going to change it unless they want the country to fall apart. But even as a 6-7-year-old, you're aware of them. There are very, very odd decisions which you think must have been contrived by the education department to make the country fall apart.
Such as?
They'd give you books on being a good communist child, and all the East German, possibly the same for the rest of the Eastern Bloc, all the children would join the equivalent of Scouts. In Germany, it's called the FDJ, which I'm not sure what the acronym stands for, which is equivalent of Scouts. Everybody gets a neckerchief. You go camping. You do all the things that Scouts do, different type of salute. But it's a blue neckerchief. And in the same books, you read about being visited by the Russian equivalent and sharing camps, and you're looking forward to the camps. But mysteriously, they're all wearing a red neckerchiefs. And you're already told, if you're very good and do all your duties and are a good communist child, one day you will graduate to a red neckerchief. So you imagine in the books they're saying, well, all the Russian ones have already graduated to that. And then you meet them and it turns out they just get them automatically. Yeah. For a child, that's already unfair, isn't it? It doesn't take much. You think, well, in hindsight, as you get older, you think, why who on earth thought that a child would ever accept that? So immediately, all of us as kids were, well, why are they getting the red one?
Yeah.
What do we have to do? Why do they get it automatically? So that's resistance that the teacher who was telling us and showing us the book hadn't expected. It's odd, isn't it?
When you, washed up, landed in Southend,
Yeah.
you were presumably German speaking.
Of course, yeah.
And was that, you're an age where I guess you can remember, was that difficult?
I'd actually spent, I think my mother had 3 kids while studying, and my gran would come over and help with the childcare. And I think she offered, why don't I take Amin, the eldest, to Baghdad for a while to give you some time. So I actually ended up in Baghdad for about 2 years.
Oh, wow.
Forgot German, learned Arabic, and then came back to Germany, forgot my Arabic, learnt German, and then immediately went to England. And you can imagine Germany's continental climate, Berlin, and nice and dry and proper snow. And you arrive in the winter in Southend-on-Sea, and it's damp and raining, and there's no snow. Yeah, it was a bit of a shock initially. But then, you have to learn English. But it doesn't take long as a child. You absorb this stuff pretty quickly.
Yeah.
You've got no choice.
But you come from a diverse, and let's face it, post-communist background. Did that lead to any issues?
Not really. No. No. You mean as a child in the 70s, Southend-on-Sea?
Yeah, 70s, 80s.
God, no.
Interesting
what
time.
Do you think in a playground somebody would say, oh, I hear you come from communist Berlin? No, not at all. It's more... I don't know if you're an Essex boy, then you'll remember. You're probably about the same vintage as I am. If you go to the school, how many non-white kids are there? It's that sort of thing.
Yeah, very few.
Yeah, exactly. So now, of course, the schools are much more diverse. But back then, you find yourself as the only non-white kid, and it's initially exotic to some kids. But we all seek out difference for teasing and all the rest of it. It could be your hair.
My hair?
I don't know why I looked at your hair. I'm imagining it was ginger.
Very sensitive about my hair at the moment.
Yeah, so it's that sort of. Those are the differences, as opposed to thinking that you were a communist child or something. Yeah.
And were you always going to be an architect?
No. I was. My parents are doctors. I'm the eldest. They expected me to set the example for the other 3 kids and become a doctor. But as the eldest, you're doing all the childcare as they're in, doing their ward rounds and working on call and all the rest of it. And you realize this is a terrible job. They're never here. Why would anybody work this hard and never be with the kids? So I opted for architecture. Didn't tell them until I got my place, and then my mother still says she has a letter that I wrote to her saying I'm going off to study architecture. It broke our heart, Amin.
Oh, really? Interesting.
Broke my heart.
I think my parents were, because both my parents are doctors, as has come up in this podcast in the past, and cousins and aunts and uncles and great-grandparents when they were alive. And they were quite relieved when I said I didn't want to be a doctor.
Yeah. It's a difficult one, isn't it? Because they felt it. There's a moral purpose to it. So if you fantasize about being a lawyer, they would argue with you why it's bad to be a lawyer. Any other profession, so you just stop talking to them about it. But all the other kids ended up in medicine because they asked me, what's it like being in a school of architecture, going to be an architect? And of course, the first thing they tell you in a school of architecture, as all other architects tell you, is you're applying for it. It's a life of penury. You're the whim of recessions. You'll all end up poor. Please don't do it. Go and do accountancy or something. So you transfer that to your siblings. And the National Health Service's job for life, fantastic pension, all the rest of it. So they just stuck to that. Yeah.
You studied under Izzy Metstone at Edinburgh, who I guess is best known for a series of extraordinary contemporary churches in and around Glasgow with Gillespie, Kidd and Coyer. Yeah. He also hailed from Berlin.
That's
of course,
right.
Left for
about the same age
very different reasons.
Yeah, exactly. Yeah.
What was his influence on your career?
Very, very bluntly, he made it clear that you have to be in control. You're the captain of your own, not just the architecture, but your own life. So It wasn't really just teaching you about the aesthetics or form or how to coordinate plan, section, the hard stuff, the graft that every architect has to do, but it's more life lessons as well. So I think because his background's roughly, sort of similar, 18th century German and Swedish anthropologists, pseudoscientists would call Semitic. We're both of the Semitic race under that definition, similar sort of family background. I used to giggle with him about the sort of stuff he used to say. Other people might be offended or couldn't take it, but it's the way that families talk to one another. So his guidance, which sometimes is a bit sort of needling, chimed with the way our family talk.
Well, it's interesting because in his obit in The Guardian, Gavin Stamp said he was both revered and feared for his incisive and often devastating criticism of student work.
Yeah.
So did you revere or fear?
Well, I think I revered him. Because he was the way he was, as you say, sometimes feared. I mean, essentially all he was doing was saying that you didn't do enough work. So some people would pin up and would expect to have a light touch criticism because other tutors would do that. But he would look at it and say, well, look, you clearly only started drawing 2 weeks ago and I set this project 8 weeks ago. Don't try and kid me, you didn't. Because, you know, I know you guys can resolve this, but because you've left it so late, you can't. It's evident. And you'd nod your head and say, yes, you're quite right. Other people would collapse under the criticism. And he wouldn't phrase it like that. I mean, there'd be guttural bits of swearing and mostly analogies. And at some point, the student body, the student cohort, I think one or two of us had really hard times with her. Got together, wrote him a letter saying, you know, this is unfair. You need to change your teaching style. So he held a meeting. And at that meeting, the leader of this revolution, as it were, started it off saying, look, Izzy, you like your analogies, but going into a crit with you is like going into a car crash. We're always experiencing these car crashes. And of course, not everybody experienced the car crashes, but clearly some people found them very difficult. We're in fear then of going into these crits. And he turned around and said, well, you know, if you're having so many car crashes, perhaps you should have your license taken away. You know? Of course, I giggled and started laughing because I thought, well, it's true. You know, if you're that terrible at it, perhaps you shouldn't be doing it. But yeah, it sort of disarmed the revolution. You know, he stayed on and well, he did eventually leave, but I think he didn't really want to. And because he realized, look, he enjoys it. If the students enjoy it, and most students up to that stage, I think it's a generational shift. You know, what they call the snowflake generation. I think we were already the initial snowflake generation who couldn't take it. And he realized, look, I like students that I get on with. And if at least half the student cohort are struggling, and I can't get on with them, perhaps it's time I did go.
Interesting. Can I ask, all this background, did that feed into the way that you've set up your own practice? I mean, everyone who stays at Groupwork for 18 months automatically becomes an equal partner, I think I'm right in saying.
Yeah. That plus working in other offices. So I spent my time going in at least 2-3 other largish offices. When I say largish for architects, that tends to be 20 plus, sometimes 50 plus.
Because you worked at Rick Mather and Lift Schultz Davis, Sandilands, Wilkinson Eyre, Zaha.
Exactly. Well done.
Thanks. That's your CV.
Well listed. One other one, Andres Berzens, who was entirely on his own.
I missed
Andres Berzens, who lived a couple of doors down from me when I first came to London. And what you realise is that it's the name on the brass plaque outside the building, as it were, and it's their name forever. And it's actually the hard work of everybody who's there that's building it. I know that they were the founders, they're the guiders, and they still often do guide and teach. But really, it's the hard work of everybody else that lifts and elevates that practice and maintains it and propels it. Lots of hard work, lots of innovation and ideas that come from people that join, as opposed to all of it from the one master, as it were. So I was determined, if I was to start up a new practice, leave independently, work independently, then at some point, as people join, we have exactly that understanding. And it's a mutual respect where, yes, I might be old and more senior and more experienced. I can give that knowledge, but it's a debate. So as you say, it's the same way that Izzy might have debated with you. You could throw those ideas about and he would quickly tell you whether that's it's going to have legs or not from experience, as it were. But then if there are new ideas, he'd be open to them and say, okay, I think that could work if you did the following from his experience. So it's that sort of relationship. So part of it, yes, about open debate, being open to criticism and not collapsing under criticism, and part of it that you reward people for their actual endeavors as opposed to it's just your name on the brass plaque and all the wealth is yours, etc. And that's probably, somebody's argued that's probably because you spent your formative years in East Germany.
Well, yeah, I mean, that's the path, the narrative path I was treading. What was it like working at Zaha's?
Do I say the exact opposite of that? The office was her family, and I think people misunderstand when they think of her as a prima donna who was super aggressive and angry and to be feared like Izzy. It's the same thing. It's she's Iraqi, the same sort of family dynamics, as it were, and because the office is her extended family for her, she treated it like a family. So it'd be very open, what people would today call verbal abuse. You might accuse your parents of verbal abuse, but it was that sort of relationship. And sometimes it'd be just I'll give you an example. She'd be on a lecture tour and she hadn't been in the office for a month, and everyone's meant to hang up their coats and bags in the hanging area because there isn't much room in that office. It was a tiny space around chairs. You'd trip up and it'd look like a mess. And of course, while she was gone, the place turned into effing pigsty, in her opinion. And she couldn't hold back and scream and shout at everybody, open the windows and throw everybody's coats and bags out as a lesson that you should never do this again. So it was like that. And as long as you understood, she would fire you on the spot because she just hated something that you did that day, your haircut or something, and literally something like that. You didn't leave, but if you were new and you didn't understand that, or you didn't have that sort of parental upbringing, saying more about my parental upbringing. If you didn't have that sort of background, understand that sort of background, you would go. And then the next day she'd ask you, where's such and such? Well, you just fired them, didn't you? You fired them yesterday. Get them on the phone. And then she'd be barking at them on the phone. If you don't get here in the next 20 minutes, you're fired. But so it was like that.
Yeah.
Fun, lots. I mean, it doesn't sound like fun, but you were given actually lots of freedom. It sounds
terrifying.
Yeah. Oh dear. Yeah. No. Well, on a more positive note, there was lots of freedom. People don't think there was lots of freedom, but actually a project would come in and maybe 4 or 5 teams would set themselves up of 2 or 3 people, and all of us would have a go at that project, have complete freedom, design freedom with it. And slowly but surely, between us all, including Zaha, she was there, we'd reduce those options and say, well, that one works for this reason, but this one doesn't have any merits at all, and then come up with a result that had the best of all of them, or that particular single idea was sort of reigned supreme, as it were. So there was a lot of freedom and fun in terms of design opportunity.
I've taken up loads of your time. I mean, so I'm coming to the end of this, but I just really quickly want to return to the raison d'etre behind this interview, which is stone and the materials. You've described yourself in Architecture Today as finding yourself as, and I quote, an inadvertent campaigner for lower and negative embodied carbon construction. Is that really how you feel? Inadvertent?
One of my last projects while studying was on sustainability. There is sort of at least 10 key lessons for every architect to work with when they're designing to make a sustainable future in construction and maintaining burning energy in buildings, etc. I tried at that time to sort of push that agenda, but you're a graduate. You go into an office. The office has a way of doing things. The industry has a way of doing things. You're just shouting in the wind. It's pointless. So you just work within the industry. And what you realize is the education system is not structured to give architects, designers, including engineers, the full understanding of materials. And that's really key to architecture. So when I say inadvertent campaigner for sustainability, really what I'm saying is that architects need to have full knowledge of all materials and make intelligent decisions about the material choices. And that's not just, it has a sustainability title. It has a poetic title. It should give us joy and delight, the architecture. But in the same way, it has to stand up and not fall on our heads. It has to stop from bursting into flames. It should also have low or negative embodied carbon, sustainable.
Very good. Final question. Plans for the future. What can we expect from you? What are you working on currently?
I'm super keen on trying to get the 30-story plus tower to demonstrate that it is carbon negative. There's a standard office building or larger residential building. At the moment, on our drawing boards, as it were, large houses, an office building, not so large, a small theatre, mixed bag, I guess, of things.
Very good. Very good. Well, look, thank you so much for your time. I really, really appreciate it. It was great.
You're welcome. Pleasure.
And to discover more about Amin and Groupwork, go to groupwork.uk.com. As ever, there are images from the interviews as well as little films and other things on my Instagram page, Grant on Design. And you can find all the podcasts that I've done, sign up to my newsletter, and lots of other stuff at grantondesign.com. Finally, and this is really important, if you've enjoyed listening and want to see this podcast flourish, then please rate and review on Apple Podcasts or wherever you listen to this from. And it would make me incredibly happy if you went to my Patreon page and made a pledge at patreon.com/Material Matters. For as little as £2.50 a month, you can receive exclusive posts, blogs, and thoughts from yours truly, as well as getting access to each episode before it's published to the wider world. Material Matters is a completely independent concern, and any help you can offer would be hugely appreciated. Ultimately, you'll be helping to take the message, the importance of materials, skill, craft, and design to a whole new audience. Thanks very much for listening.